All right, I'm very excited for sharing this tool. This is the same tool that we have been using with our enterprise customers. We are making available for free to any developer to try the power of Dynamic Flow Network. And so basically this new update, this allows you to add events in the past and events in the future, if you want to simulate how things are going to behave. This could be applying retail, finance, energy, whatsoever. And again, what makes this powerful is that you do not need to calibrate the model, try to make the model work for your data. The model learns itself from the data. So you just upload the model, upload the data, and is able to understand the cause effect, the correlations, everything. So you can explains everything to you because it has the reasoning capabilities. So you can actually make sense of the data. In the future, in the past, it's amazing. So let's get started. So the first thing that we are going to do is right now the design of the platform is improved. I hope. So the first thing that you need to do is to upload the files. There are two files that you need to upload. You can upload just one. It depends on what you're doing. So you need to upload, of course, the training data. We are going to use this file here. And now you can also upload future events in a very simple terms. If you have promotions in the future, if you have sales of the store and you want to add the promotions of the future because that will impact the forecast, this is where you upload this data. All right. So I'm going to show you what that data is. So the training files is this. Is this more or less the same as the last update? So you have the column with the node IDs, basically describing what you want to forecast. You have the column with the dates. You have the column with what you want to forecast. In this case, it's sales. And now you have the columns with events. You can have multiple columns with events, all right? Right now, we are going to add just one, promotions. And all the events need to be numeric. They need to be numbers, integers, floats, whatsoever, but need to be numeric. All right, so we have this. This is the first file here, very simple. Dates, sales, and the events. And we had now the second file, which is the future. What we have from the future that we know for sure that's going to happen. And this is the second file, which is basically the promotions from the future. All right. So again, we need to have the IDs, we need to have the dates, and we need to have the same column, but with future promotions. So you see it is the same name as this file here. All right. Those are the two files. And this is the only thing that we need. All right, so let's name this model as store with sales and promotions. All right, so the nodes is again description, the column with the values, the things that we want to forecast. This is the dates. Now we have to specify what is the frequency of the dates that the file has. In this particular case, you can see this is daily sales. All right, so we just put here daily. Event training. This is where we place the columns with events. In this case, we only have one column. If we have multiple columns, we could add here. All right. Right now, we only have one column. And now the future events, the second file. This is for the training, and now this is for the second file. And again, is the same. It needs to have the same name as the training. All right. So if you have promotions in the future, we need to have promotions in the past. All right. So we would have something like this. If you do not know what is going to be the weather in the future, we leave it like this. But these events here needs to exist on the training data. All right. So let's move on. Let's analyze the next 8 weeks. All right. So right now the data has dailies, but we want to do weekly. So of course we are talking about sales data. So the data needs to be summed because we are aggregating by weeks. And let's see what the model gives us. All right, it took a few seconds to run the 10 products of this model. So let's take a look. let's go through to this product here, AquaPure still water. This is a very interesting example to share with you. So this is what you get with just these two files. You get all the information that you need first to understand the data, to understand the future, and how you can manipulate the future. For example, in this case, let's see what the model is thinking, how the model creates the forecast, how the model analyzes the data. The first thing that the model does is to understand if it's able to train from its own data. So we have, in this case, if I'm not mistaken, 10 products. And the first thing that the model is going to do is to just train from from this node only. And if it does that, the current uncertainty is 38%. So the model finds that the uncertainty is a little bit high. So it's going to analyze if there is external behavior relationships. The first thing that the model is notice is that when an event is done for this product itself, a promotion, it has an impact over the next 9 weeks. All right. So just by analyzing the cause effect of all the structure of this data, is able to understand that when a promotion is made to this product, this is not just creating an impact that is static in time. It only happens when the promotion happens. No, because it makes sense, right? Because if you buy soda, you are going to consume that product over the next days, over the next weeks. So a promotion might have an increase in sales in this product, but will have an effect over the next 9 weeks. Now the model is going to try to understand if the other nodes, the other products, have an impact on this product. And it detected this. There is a correlation with two products. Correlation, not cause effect, correlation. Classic Cola has a divergent behavior with this product. And Berry Blast Fruit Chews have a similar behavior with this product. What that means? When we talk about correlation, it means that this product behave in the same way on the same context, right? So does not mean these products are cannibalizing each other or they are there's a cause effect between both. No, that's not what it means. What it means is that on the same context, on the same macroeconomic context, they behave the same. If there is an inflation, for example, the purchasing power of the consumers change, these products will have the same behavior or divergent behavior. So they are not cannibalizing each other, they are not working together, but on the same context, they behave the same. Then the model was able to find that specific promotions on these two products have an impact on this product. So right now we are talking about cause effect, not correlation. We talked about correlation before, now we're talking about cause effect. A promotion on Classic Cola will have a negative impact on AquaPure Still that lasts for up to 5 weeks. This proves that this product is actually cannibalizing this product. They just not share correlation, anti-correlation. They also share cause effect. They are cannibalizing each other if you prioritize one over the other. And it lasts 5 weeks if you give a promotion to Classic Cola. And because of all these analysis, the model was able to decrease the uncertainty from 38% to 30% based on all these cause effects and correlation is able to decrease that. So we have this. And just to make it clear, even if the uncertainty is 30%, it does not mean the precision is around 70%. No, the uncertainty only means that the model was not able to find all the cause effects. It needs more data, could be weather, for example, weather data. But it's able also to forecast with over 90% accuracy, but the uncertainty might vary a little bit for specific days or specific hours, depending on the situation. That's what the 30% means. All right, so thank you very much. This is all for now.